Calculator. Creation of a 2 sides PA weld inspection using sectorial scan. The specimen. The first step into creating a setup is defining your specimen. It will help you create your UT configuration and also help you with data positioning. We will begin by creating a 19mm specimen. We will create a UT phased array configuration for the following specimen. It is a 19mm thick plate with a 30 degrees V weld. Once the specimen is done, click Accept. To display a drawing of your specimen on the sectorial scan, activate the overlay and select how many full skip you want to display. For more information about how to create your specimen, please watch the 2 specimen creation video from this series. Creating a Skew 90 channel. Let's start by creating a phased array channel to inspect the left side of the weld, skew 90 degrees. To create your UT configuration, go in the Channels menu. By clicking on the Current Channel button, you can rename your channel. In this case, we will name our channel Skew 90. Then, select the configuration you want to create. In this case, we will select Phased Array Pulse Echo. And select which probe and wedge will be used. You are now ready to start creating your focal laws. Click on the calculator. By default, your skew angle is 90 degrees. Multiple sweep types are available. Let us go ahead and look at a few examples. First, we have the Azimuthal Sweep. The Azimuthal Sweep uses the full aperture to create each beam. As seen in the animation, the same set of elements create each focal law by applying different delays. Our next example is a linear sweep. A linear sweep uses an aperture that moves along the probe to create each beam. As seen in the animation, each set of elements creates one focal law. Then, move by the selected resolution and create another one, and so on, always applying the same delays. Lastly, we have a compound sweep. A compound sweep uses an aperture that moves along the probe to create each beam. As seen in the animation, the set of each elements creates one focal law, and then you need to move by the selected resolution to create another one, and so on, applying different delays to create each angle. In this case, we will select the Azimuthal Sweep. Then, as seen previously, you have to select a start and stop angle for your inspection. And we will use an aperture of 16 elements to use all of the elements available in that probe. The reverse probe could be used if the probe was set up upside down on the wedge so that the first element is at the top of the wedge instead of the bottom. As for the focal point, you have to choose between half path and true depth. Let's take a deeper look. In this image, you will see both a true depth side and a half path side. The true depth shows that all the focal laws focus at the same depth inside the material. The half path shows that the same distance along each focal law is the same. In this case, we will select half path with a depth of 52 millimeters along each focal law. The position of the focal point is displayed on the left, displayed by a black dot and a black line. You can also set up your time base directly from the calculator, or set it to the none in the calculator and set it up later in UT settings. Let's set it up with the calculator. 3 options are available: half path, true depth, and distance. You can visualize your selection by looking at the red area displayed on the left. Half path and true depth use the same concept as for the focal point. As for distance, it's a distance from the center of the weld. The selection of the time base will affect the display of your sectorial scan and the length of your A-scan for each focal law to display only what's in the red area. Finally, position your probe on the plate by grabbing the wedge and moving it directly to the display. You want your lower angles to look at the top of the weld and your higher angles to look at the bottom of the weld. Once you're satisfied with the display on the left, click Accept. Next, we are going to create a Skew 270 channel. To create the channel for Skew 270, we first need to create a new channel that will be a copy from Skew 90. Every time a new channel is created, it will be a copy of the channel that was selected previously. If we want to inspect both sides of the weld at the same time, we need to create a second channel. To do so, click on the current channel button and select New. Name your new channel. In this case, we will name the channel Skew 270. Creating a new channel, you must always copy the currently selected channel. So all the parameters from channel Skew 90 have been imported in Skew 270. You can verify your parameters by opening the calculator. The only thing we have to modify to this channel are the skew angle and the probe connection. Change the skew angle to 270. You can see your probe moving on the display. Finally, change your probe connection according to your splitter cable. If you're using a Z-Tech splitter, the first connector uses connections 1 to 64, and the second connector uses connections 65 to 128. You want your probe connection in the calculator to be the connection on which your first element is connected. In this case, it's connection 65. To see your full weld coverage, tap the button at the top right corner of the left display. Once you have made all the necessary modifications, click Accept. Now that you have two channels, one for each side of the weld, let's display them both at the same time. For a simple layout, the predefined layouts can be used. To do so, tap on any view and select the last button of the contextual menu. The predefined layout list opens. Select the appropriate layout for your setup. In this case, we will select the 2 volume corrected with the 2A scan because we have a 2-phased array channel. To create a custom layout, please refer to the view layout video of this series. Thank you for watching. If you have any questions, please contact us at support-utproducts@ztech.com.